Hi students, welcome to my channel, Crack Physics with Anisha. Let's make physics concepts simple, fun and clear. Moving to the next question, find out the following in the electric circuit given in the figure. First, effective resistance of two 8 ohms resistors in the combination. Second, current flowing through the 4 ohms resistors. Now, first of all, we can observe study this particular circuit diagram. We can see that 8 volt is the input voltage given to the circuit, that is the cell connected. And we have a 4 ohms resistor which is connected in series combination or series connection with this 8 volt. And we have two 8 ohms resistors which are connected in parallel to each other, and together it is connected in series with this 4 ohms resistor. Now our task is to find out the effective resistance of two 8 ohms resistors in the combination. Now from the figure we already said these two 8 ohms resistors are connected in parallel to each other. Why? Because this 8 ohms resistor like CD connection, you can see first one has one end connected to the junction C, the other end connected to junction D. For the second 8 ohms resistor, again one end is connected to junction C, the other end is connected to junction D. Both of them shares the same junction, right? So we can say that both of them are connected across each other, parallel to each other. So we can write 8 ohms is parallel to each other, isn't it? Both the 8 ohms resistors are parallel to each other. So how we'll find the effective resistance of parallel combination? Is 1 by Rp is equal to 1 by R1 plus 1 by R2. Now, effective resistance, total resistance, net resistance, equivalent resistance, all are same. You have to find the total resistance. So here it is 1 by R1 plus 1 by R2, as there is only two resistors connected in parallel. So that is 1 by 8 plus 1 by 8. Now we know that the numerators and denominators both are same. As denominators are same, add the numerators, so 2 by 8, that is equal to 1 by 4. So here we got 1 by Rp equal to 1 by 4. So take the reciprocal to find the effective resistance. Rp is equal to 4 omega. So it says that instead of connecting this two 8 omega resistor parallel to each other, we can connect a 4 omega resistor. A single 4 omega resistor is enough. That also give the same result. Okay, so that is the effective resistance between two 8 omega resistors connected in parallel combination. Now second one, current flowing through the 4 omega resistor. 4 omega resistor means the resistor connected between the points A, B. Okay, so by observing this figure, we can see this 4 omega resistor connecting between the point A, B is in series connection, right? Yes, series combination. They are not asking about this effective 4 omega resistor. They are asking about this AB resistor. So, we know in a series combination, the current through each component will be the same because current has only one single path to travel. But the voltage or the potential difference across each component will be different. That's what we have learned, isn't it? So, here, when this 4 omega resistor is connected in series, we can say the current through this 4 omega resistor will be equivalent to the total current in the circuit, right? Yes, the total current in the circuit. And we can see this two 8 omega resistors are together connected in series with this 4 omega resistor. So, if we find the total current in the circuit using the relation Ohm's law, I equals V by R, where we take V as the total voltage and R as the total resistance, we get the total current. If you get the total current, that much current is passing through 4 omega resistor. So total voltage is already, it is given as 8 volt in the question, the figure it is given. Now what about the total resistance? Total resistance means, yes, one, it is 4 omega, the other one 2 8 omega connected in series, not series, a parallel, together connected in series with the 4 omega. Now the effective resistance of the two 8 omega resistors connected in parallel, we already got it as 4 omega. So if you redraw the figure, it will come like this, isn't it? This is the 4 omega resistor between the point AB, and then we have C, then we have another 4 omega resistor. Instead of connecting to 8 omega, we are connecting this 4 omega resistor. Yes, this is the figure. So these 4 omega resistors are coming in series to each other, end-to-end connection. After the first resistor, we are connecting the second resistor. So you have to take the total resistance of series combination, and that is R1 plus R2. Simply take the sum. So R is equal to first one, it is 4 omega plus the effective resistance of the other two, it is again 4 omega. So we get it as 8 omega. Yes. Now substitute this total resistance in the equation of current. So I is equal to V by R means total voltage, that is 8 volt, by total resistance, it is 8 omega. So we get cut each. So we'll be getting 1 ampere as the current, total current flowing through the whole circuit. So that much current itself will flow through the first 4 omega, right? Yes. So the current flowing through 4 omega is equal to 1 ampere because 4 omega is in series combination. Yes, is 1 ampere. So that is the final answer. Next question. Study the circuit and find out the current in 12 ohm resistor and difference in the readings of ammeter A1 and ammeter A2, if any. Yes, so in the circuit we have a 6 voltage battery used. Two 24 omega resistors are connected across each other like parallel to each other, and a 12 omega resistor is connected in series in the circuit. So first of all, the question is to find the current in the 12 omega resistor. Now this 12 omega resistor is basically, I told you, it is in series in the circuit, series combination. It's clearly given, right? It is in series combination. The end of the 12 omega resistor is connected to the battery and the other end is connected to the other component. So series. So if we have to find the total current in this 12 omega resistor, we can find the current flowing through the circuit. Now in series combination, as we have discussed before, always remember the current will be same through all the components, but the voltage will be different across all the components. Now, this 12 omega resistor is connected in series with both of these 24 omega resistors. Even though they are parallel to each other, together they are in series with this 12 omega resistor. So if we find the total current in the circuit, we know that much current will pass through what this both 24 omega resistor together, and here definitely it will split. The current will split because there are two paths. Again the current rejoins here, and then you can see the same current will pass through this 12 omega resistor also. So how we can find the total current in the circuit? That is using Ohm's law, total voltage by total resistance. That is fine, isn't it? Now how we can find the total resistance? So here we know 224 omega is there, 112 omega is there. So these 24 omega resistors are parallel to each other. So first of all, we can find their effective resistance. How we can find the effective resistance of parallel combination? Yes, it is 1 by Rp is equal to 1 by R1 plus 1 by R2. So here we can write this 1 by Rp is equal to 1 by 24 plus 1 by 24. Very easy. Denominators are same. So add the numerator, that is 2 by 24. So that is equal to 1 by 12. So we got Rp as 12. We have to take the reciprocal, right, to get the effective resistance. So Rp is 12 omega. That is the effective resistance when we connect two 24 omega resistors together. So if we redraw the figure, we can see there will be a 12 omega resistor which is in the place of two 24 omega resistors that can be replaced. Same effect only. Then we have another 12 omega resistor connected in series like this, and this is the circuit. Yes, this is the simplified circuit. Now, what we have to find? We have to find the total resistance. How we can find the total resistance? This effective resistance between 24 omega resistors and this 12 omega resistor. They are in series combination, end-to-end connection, right? So you can use that formula. So that is R1 plus R2, and that is equal to R1. It is the effective resistance of 24 omega resistors, 12 plus R2 is 12 already given, that is equal to 12 plus 12, it is again 24 omega. So 24 omega is the total resistance in the given circuit, effective resistance in the given circuit. So we can find the total current. So total current I is equal to the total voltage by the total resistance, and that is equal to voltage is given 6 volt in the question. Now that is divided by 24. Yes, 6 by 24 is basically is 1 by 4. So 1 by 4 is equal to 0.25 ampere current passes through this whole circuit. So from this voltage, this battery, we can say 0.25 ampere current is passing through it. At this junction, this current will split up, but still it rejoins at this point and then it passes through the 12 omega resistor. So we can say the current through 12 omega resistor will be, yes, 0.25 ampere. Now, second part of the question, difference in the readings of ammeter A1 and A2. Now, ammeter A1, that gives the reading of current passing through this particular line, right? Yes. How much current passed through this 24 omega resistors all together will be shown in A1. Likewise, A2 will be showing the current passing through, yes, this particular line. Whatever be, no problem, we understand that these current, these current is constant throughout in the whole this circuit diagram, right? We know 0.25 ampere current reaches here, it's split up, but still it rejoins here and forms 0.25 current only, right? So 0.25 current will be shown in resistor A1 as well as in resistor A2. Both of them, A1 gives 0.25 ampere current. Likewise, that same current passes through 12 omega resistor and then it passes through A2. So A2 will also shows 0.25 ampere current. So both of them will not have any difference in its reading. They are having same readings. That is the answer for this question. Moving to the next question. There are two parts. We'll discuss the first part and then we'll move to the second part. A, you are given four resistors each having resistance R ohm. Find the maximum and minimum resistances that can be made with these four resistors. So we'll discuss that first, then we'll move to the next one. So we have four resistors, each having resistance R omega. So we are taking like R1, R2, R3, R4. These are the four resistors. All of them have same resistance. We can take it as R ohm. What will be the maximum and minimum resistance that can be made with these four resistors? So we know only two types of combinations of resistors. First one, it is series combination, right? And second one, it is parallel combination. Now, when we consider the series combination, we know that the effective resistance can be found using the relation R is equal to R1 plus R2 plus R3 plus, as there are four resistors, I am taking 4, R4, and we know all are same, so I can write it as R plus R plus R plus R. Yes, that is basically 4R, correct? Yes. Now, in parallel case, the effective resistance we can find using the relation 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Now, all the denominators, the resistances are same, so I can write it as 1 by R plus 1 by R plus 1 by R plus 1 by R. Denominator same, so I can add the numerators, that is 1 plus 1 plus 1 plus 1, that is 4 by R, that is 1 by Rp, so we get Rp is equal to R by 4. So Rs, when we connect all the four resistors in series, we are getting 4R omega resistance, 4 times the resistance of the individual resistance we got. Yes, but when we connect them parallelly, we are getting 1 by 4th time of the individual resistance as the effective resistance. And if we connect like both the combinations together, two of them in series, two of them in parallel, and connecting them together. Likewise, if we choose any other combination also, we'll be getting a value which is in between this R by 4 omega and 4R omega. So from this relation, we can say that when we connect the resistors in parallel combination, we'll be getting the minimum resistance. Okay, the circuit will be providing minimum resistance. But when we connect the resistances in series combination, it provides the maximum resistance. Always keep this in mind. In series combination, it gives maximum resistance. In parallel combination, minimum resistance. So from the values itself, you can see RS is 4R omega effective resistance, 4 times individual resistance. And RP is R by 4 omega. That means 1 by 4th of individual resistance is only obtained when we connect the resistances in parallel. So always it is better to connect the circuit, the appliances or the components in parallel combination in order to reduce the resistance and increase the current flow in it. Yes, so it is always better to choose parallel combination. That's about this question. Now we'll discuss the OR question. The question is given. A copper wire has a length L equals 2 meters, a cross-sectional area A equals 0.5 millimeter square, and resistivity rho equals 1.7 into 10 raised to minus 8 omega meter. Calculate the resistance of the another wire made of same material whose length is twice the length of the wire but has same cross-sectional area. So remember, whenever numericals are given to you, take down the data written there. So length is written as 2 meter for the wire. Cross-sectional area is given as 0.5 millimeter square. And the resistivity of the material is given 1.7 into 10 raised to minus 8 omega meter. Now we have to find out. So this wire will have a resistance of its own, right? But we have to find the resistance of another wire, a new wire. So we can take it as R dash of same material they have said. So we have to find the new resistance with same material. That means the new resistivity will be same as the old resistivity because it is made up of same material. So 1.7 into 10 raised to minus 8 we can take, right? Now length is twice the length of the original wire. Now new length I am taking it as 2 times L, twice the length of the original wire, that is 2 into 2 meter, that is 4 meter. But its cross-sectional area is same. So A dash new area is same as the old one. If you get all these values, we can simply substitute and find the answer. We have to find the resistance. We know the relation connecting resistance, resistivity, length and area. What is it? Yes, R is equal to rho L by A is the relation. Now here we are finding the relation for new resistance. So new resistance R dash is equal to, again rho dash is same. Rho we can take. L is new. We can take it as L dash divided by area. It is same. So we can take it as 8. So substitute the values, that is 1.7 into 10 raised to minus 8 into L dash means it is 4 meter divided by area of cross section. It was 0.5 millimeter square. Converting it into meter, you have to divide by 1000 and it's square. Millimeter converting to meter, how you can convert it? Yes, you have to divide by 1000. Yes, if millimeter square is converted to meter square, divide by 10 raised to 3 whole raised to 6, isn't it? So not 6, 2. So we'll be getting 10 raised to 6 as the denominator. So I'm simply writing it like this, multiplied by 10 raised to minus 6. That is fine. Correct. Yes, I have to divide by 1000. So if it is 0.5 divided by 10 raised to 6, taking it to numerator, it will become 10 raised to minus 6. Right? Now, when you solve this problem, you will be getting 13.6 into 10 raised to minus 2 omega as the resistance of the new wire. Okay. Better you don't touch the powers of 10, keep it like that itself. That means you multiply the numbers 1.7 into 4 divided by 0.5. Then power of 10, keep it like that itself. 10 raised to minus 8 is there. Now taking 10 raised to minus 6 to the numerator, it will become 10 raised to plus 6. Solve these power and write in the final answer. That's how we are getting 10 raised to minus 2. And you know how to calculate 1.7 into 4 divided by 0.5. Just multiply by 10 in numerator and denominator, we'll get the final answer. So this is the resistance of the new wire, 13.6 into 10 raised to minus 2 omega, or you can write it as 0.136 omega. Next question. The above image shows a corrective measure for a particular defect of vision. First, identify the defect of vision and state what kind of lens is used to correct this deficiency. Second, draw and label a ray diagram that shows the defect of vision in the above case before the correction. So we can observe this ray diagram. We can see it is an eyeball with the crystalline lens. A convex lens is kept in front of it, and we can see this convex lens is converging the image of the object at retina. Okay, and you can see the object is near to the eye. So if there was no convex lens, definitely the person cannot see the image properly because the image will not form on retina, right? Yes, when the convex lens was used, the person can see the image at a point here, like this point, the person can see the image. So if the object is at this point N near to the eye, and when we use the convex lens, he can see the image at this point N dash. Yes. So what is the defect here? The eye defect is nothing else. It is hypermetropia. Hypermetropia. Now, what is hypermetropia? A defect in which the person can see only the distant objects clearly and the nearby objects are not at all clear for them. So, if this person is not using the convex lens, that person cannot see the image because the image will not form on retina, right? Yes. So, in order to make the image to fall on retina, the person has to use a convex lens. Okay, so here the lens is given as bulged out, so definitely we can use a convex lens to, yes, correct this defect. Why we are using convex lens, that one we can discuss when we start drawing the ray diagram for this defect. So in the next part of question, we have to draw and label the ray diagram that represent this eye defect before correction. Now it is very important to draw and study all the ray diagrams of the eye defect as well as how it can be corrected. So in the case of a hypermetropic eye, we know that without a corrective lens, when the person observe a closer object, this N dash represent an object closer to that particular eye, the image of this object will be forming behind the retina. So we know that if the image falls on the retina, then only the light sensitive cells can detect them and we can see the object. But if it is falling behind the retina, there are no light sensitive cells over there. It's only on the retina. So the person cannot see the objects. But the faraway objects are clear to them. Only those objects which are near to the eye, closer to the eye, are not visible. That means their near point is not just like a healthy person. It is not 25 centimeter. Their near point will be somewhere about 25 centimeter. That's why they cannot see the images. Yes. Now, how we can see these images? We have to bring back the image formed onto the retina. Now it is formed behind the retina, right? You can see. But you have to bring back that onto the retina. By using a convex lens, you can reduce the focal length. You can reduce the focal length and make the image fall on the retina that is given in the question. The figure given in the question. Now, you have to draw and study. So, the Z dash represents the object closer to the eye and N represents object which is far away from the eye. So, when we use a convex lens, what happens? The convex lens will bring the image on the retina and the person can see the object at the position N dash, like given in the question, you can see, no, it is N dash. So at a far away point only the person will be seeing the object, not in its real position. In a virtual position the person sees, but still they can see the object using a convex lens. So this light ray represent what? The incident light ray from the closer object. After refraction through the convex lens, the eye lens, it will focus or it will converge at a point behind the retina. This is the figure. So here is, you can label the diagram. This is our crystalline lens, or you can write it as eye lens. This is the cornea Yes, this is the closer object, and the other one, it is the ray diagram, and here is the image formation. This represents the retina. Draw and study the ray diagram. It is very important. Thanks for watching. Subscribe for more videos. Hit the bell icon and join our learning journey.